Hey guys, today we're going to take a look at properties of limits. Now, you'll notice that my handout is complete already. This is my third time going through this whole thing. I did go through it twice, not realizing that the camera was not pointing anywhere that I was looking. That I did it once is a little embarrassing, but that I did it twice is quite embarrassing. So anyway, we'll go through and hopefully I don't screw up again. But anyway, so first thing we're going to look at here is just 8 simple rules that apply to limits. Now this is for any real number a, and this is supposing that f of x and g of x both have limits that exist at x equals a. So number 1 here is if we've got the limit of a constant. So the limit of a constant is just going to equal the constant because there is nothing that's changing. There's no x to even approach a, really. So it's just always going to equal that constant. Okay? If you have the limit of x, as x approaches a, it's just going to equal a. And that one's fairly straightforward. That kind of goes back to the direct substitution that we talked about in the last video, and we're going to talk a little bit more about in a second. So the rest of them are all pretty much the same idea. They follow the same pattern anyway. So if we look here, we've got the limit of a constant times a function. So the limit of a constant times a function is just a constant. It's the same as that constant times the limit of the function. You don't have to multiply the function by the constant and then calculate its value. You can just find the limit of the function and then multiply it by the constant. Similarly, we've got the limit of a sum or a difference is going to be the same as the sum of the limits of the, or the sum or the difference of those limits. Okay? So in other words, we can either take a f of x and add it to g of x and then find the limit, or we can find the limit of f of x, find the limit of g of x, and then add them together, or subtract. Okay? We've got the product. So the exact same thing here. Okay? We can find the product and then find the limit, or we can find the limit of each of those individual parts and then multiply them. Okay? The division rule is the exact same as well. However, you do need to make sure that the limit of g of x does not equal 0. Okay? Because of course you'd be dividing by 0. Okay? Similarly, we've got the limit of a function to a power, or it's the same as taking the limit of the function and then putting it to the power. And the same with the radical here. If we've got the nth root of a function and we're finding the limit, we can just find the limit of the function and then take the nth root of that answer. Okay? So moving on, we're going to look at 5 techniques for how to evaluate limits. Okay? We're going to start off with the easiest one. This is the one we talked about in the last video, and you can see there were 4 examples here, and I'm just going to I've done 2 of them for you. You can do the other 2 yourself, because these are fairly straightforward. Okay? Because there's no reason we can't let x equal 2 in this first one, there's nothing to prevent it. Okay? The things that we have to worry about are you can't be taking the square root of a negative number, you can't be dividing by 0, things like that. And that's usually what's going to happen. But if it doesn't happen, there's no reason we can't just evaluate the limit at that value. Okay? So right off the bat, we're just going to take all the x's and we're going to substitute what it's approaching. So in this first one, we're going to substitute in the 2. Okay? Make sure you replace all of the x's. So there's 2 x values in this first one. Make sure you replace both of them with the 2. Okay? And then we do our multiplication and we add them up and we get 15. Okay? For our second one, what we had to be careful of before you can just do this method is you have to look at the bottom here and you have to say, well, if x equals -1, is this bottom going to equal 0? Because that is the problem that we run into. But as you see, it doesn't. It actually equals 1. So we can just substitute, and again, make sure you get every single one of these x's. The most common mistake I see in problems like this is people will hand me something and they've replaced a couple of the x's and they can't figure out why they still have an x in their answer. You have to replace all of your x's with the negative 1. Okay? So once you've done that, it's a simple matter of calculating it. You can just punch it right into your calculator. It doesn't matter. And you will find that you get positive 8. Okay? So I'm going to let you do the next two by yourself. And I'm just going to skip on to the more challenging ones. So method number 2. Method number 2, if you've been paying attention for the last couple of years, this one's actually fairly easy as well. However, a lot of people do have some troubles with factoring. So this is no time like the present to, make sure you know what you're doing when you're factoring. So if we look at the first one here, the problem now is as x approaches 4 is what we're evaluating, but if you look at the bottom, we've got x minus 4. So if we substitute in an x as a 4, we're going to be dividing by 0, which is not okay. Okay, so the most simple solution when that is the case is to just factor and simplify. Okay, so we go through, and you can see the top. We're looking for two numbers that multiply to positive 4, add to negative 5. So we had negative 1 and negative 4. Okay? So we write it out in factored form there, and you can see that we had an x minus 4 on the top. We had an x minus 4 on the bottom. Now, remember that you can only cancel these things if these are separated by multiplication, which it is here. Okay? If you just had a plus 4 at the end, you wouldn't be able to cross out the plus 4s because it would be separated by addition in that case. So it has to be separated by multiplication in order to cancel. And that's a very, very common mistake that people make. But this is multiplication, so we can just cross out, or we can say x minus 4 divided by x minus 4 equals 1, so those just disappear. And we're just left with the x minus 1. Okay? And because there is no fraction anymore, there's nothing to worry about for direct substitution at this point. So we can just sub in the 4, and we find that our answer is 4 minus 1, or 3. Okay? And that's it. So if we move on to the next one, this is the exact same idea. The only thing that's different about this one is you do have to remember what your different factoring techniques look like. So in this case, we've got ourselves a difference of squares on the top. Okay? Make sure you know your difference of squares because they come up all the time. They come up over and over and over again. So anyway, so we write out our difference of squares. We've got x plus 4, x minus 4. Okay, and then you can see that we've got an x plus 4 on the bottom. So once again, those two are just going to cancel out. We're left with x minus 4. Okay, at this point, there is no denominator, so we can sub in minus 4 for the x, and we're left with negative 8. Okay. So I had left this third one for you to do on your own, but since I haven't actually done anything in this video yet, so we might as well do it together. So we're going to say the limit as x approaches 2. Now, one thing to point out, especially, well, I guess it's more so for these next ones where there's, several steps before we're able to sub things in. You do have to make sure that if you haven't subbed in the value yet for x, you must be writing the limit every single time. Okay, if you don't write that, technically what you've written is wrong. Okay, and you will lose marks for that. Likely that will be a communication mark. Okay. So anyway, we're going to look at the top. Okay, we need two numbers that are going to multiply to give us negative 2, and are going to add to give us negative 1. Fortunately, there's not a lot of numbers that multiply to 2, so we know that one of them's a 2 and one of them's a 1. We know that they're different because they multiply to a negative number, and we know the bigger number is negative because they add to a negative number. Okay, or yeah, I think I said that wrong. Whatever, you understand. Okay, multiply to a negative, so they have to be different. add to a negative, so the bigger of the two numbers has to be negative. Okay. And on the bottom, same thing. We want two numbers that multiply to negative 6, add to positive 2. Okay, so because they're negative, we know they're going to be opposites. And because they add to a positive, we know the bigger one is going to be positive. So we're going to have positive 3 and negative 2. Okay? So at this point, you can see that we've got a negative 2 here. We've got a negative 2 here. So those can cancel out. And we're left with the limit as x approaches 2 of x plus 1 over x plus 3. Okay? And because it was the x minus 2's that canceled out, we can now look at this and we can just sub in a 2. There's nothing to prevent a 2 going in there because we're left with 2 plus 1 and 2 plus 3, or 3 over 5. Okay? And that's it. So, that's method 2. So let's take a look at method number 3. So method number 3 is called rationalization, and this is why we reminded ourselves of how rationalization works on the first day of class. So let's see if I can get it all to fit in there. There we go. So you can see this is one of the longer ways. So it's not actually, it's not necessarily intense math, but it's very finicky. You have to really pay attention because it's very, very easy to make mistakes. Okay, so we're going to go through and again, x is approaching 0 here. We've got an x on the bottom. So we can't just sub in a 0 because that's going to give us a divide by 0 problem. Okay? So we're going to look at this and we're going to say, well, let's multiply by the conjugate. Now, in this case, and actually in both cases, we're multiplying by the conjugate of the top of the fraction. Sometimes you'll multiply by the conjugate of the bottom. It'll vary question to question, but in this case, we're going with the top. So we had the square root of x plus 1 minus 1. So we're going to multiply by the square root of x plus 1 plus 1. Okay? And because we did it to the top, we now have to do it to the bottom. So we multiply it as well. Okay? So in doing so, we're going to be left with this. Okay? This is using the difference of squares model. And so you can see we take this square root of x plus 1 and we're going to square it, which just gives us x plus 1. Then we've got a 1 on the end, and we're going to square it, and it stays as 1. Okay? And then you always have a minus in between because it is a difference of squares. Okay? And on the bottom, you can see we had an x, and then we had this stuff over here, so we just have the x times all that. Don't forget to put your brackets in there. It's very easy to miss brackets and then accidentally multiply something that's not supposed to be multiplied or not multiply something that is supposed to be multiplied. So anyway, we got x plus 1 minus 1 on the top. Obviously, plus 1 minus 1 equals 0, so we're just left with an x on the top. Okay? Because we got an x on the top and an x on the bottom, we can just divide both of those out. Okay? So those go away, and we're just left with 1 over the square root of x plus 1 plus 1 on the bottom. And at this point, there is now no longer any reason that we cannot sub in a 0 for the x value. Okay, we're no longer having that divide by 0 problem. Okay, so you just sub in your 0, and once you do that, you can see I started to write the limit, but remember, once you do that substitution, you no longer have to write this limit part. Okay, which you will be happy because you're going to get sick of writing limit, but that's the way it goes. So anyway, we sub in our x, we get 1 over 2. Okay? So that's that one. So let's take a look at this other one. Again, this is it's exactly the same steps. Okay? This one, it gets a little hairy just because there is more to it, but it's not any different procedurally. Okay? So we had the square root of x plus 5 minus the square root of 5 minus x. So we multiply by the conjugate, okay, which is just switching that middle sign, right? That was a negative, now it's a positive. And then we're going to multiply both the top and the bottom by it. Okay? So we square the square root of x plus 5, and we're left with x plus 5. And we square the square root of 5 minus x, and we're left with 5 minus x. Now this is where a lot of people will make mistakes, because this is extremely easy to make a mistake here. Okay? Make sure you put this part in brackets, okay? Because that negative there is going to apply to the 5, and it's going to apply to that minus x. So when you get to the next step, when you drop those brackets, you'll have x plus 5 minus 5, and then you'll have plus x. Very, very easy to leave yourself with a negative x by accident, and that will give you the wrong answer. So anyway, the bottom, nothing's really happened with the bottom. Just make sure you've got your brackets there. And once we collect the like terms up on the top, so we had x plus x gave us 2x, and then we had 5 minus 5, which gave us 0, so we were just left with 2x on top. Okay? And then we were able to say, well, we got an x on top, we got an x on bottom, so those will cancel out nicely. And we're just left with 2 over root x plus 5 plus root 5 minus x. And at that point, there is no reason we can't sub in as 0 for x. Okay? We're no longer dividing by 0. So we do that, and you can see again, at that point I stop writing the limit part. Okay? And so it simplifies to 2 over 2 root 5. The 2's cancel out. We're left with 1 over root 5. And of course, you're not supposed to have a square root in the bottom. So we multiply by root 5 over root 5, and we're just left with root 5 over 5. Okay? And that's that. So those are the first 3 methods. I'm going to split up the lesson today into 2 videos so you can take a break, and we'll come back and do the last 2 methods for evaluating limits.